Hello everyone. Today I'll be talking about unlocking reusability with generically typed Vue.js components. So first let's start with what is generics or what are generics? Well, TypeScript generics are at the same, like it's twofold. It's one of the most powerful features of TypeScript that enables us to do so much. It's involved in almost everything that's beyond the basics of TypeScript. If it's like map types, recursive types, and using generic as types, it's a lot of power just in the generics use case. However, today we are just interested in using them as types for our components. And the biggest problem that I always see with TypeScript users when they first learn generics is they see it as an intimidating feature. It's really hard to grasp. It makes your code a little bit spaghetti, but you need to learn how to read it, how to understand it, and how to parse it in your head. So I think it's better with examples. So let's start with this simple one. We have a function called last item. This function just returns the last item of an array. Now, you have a few issues with this function. Let's say we want to make it strongly typed. So that means it needs to have a dynamic type, right? Because you can pass it an array of strings, and the last item should be a string, or an array of numbers, and the last item should be a number. And if the array has mixed types, then the return type should be a union of all these types. Now, you can't really do this without dynamic types, and generics are the way to do that with dynamic types. So this is how I would read a generic function. I would say I have a function called last item here, and it operates on a type called thing. Now, we don't know what the thing is going to be, and we don't care. Notice in our code, in our function code here, we don't really care what the thing is, and we aren't really interested in anything about it. We are just interested in it being passed to us. So the first argument is an array of that thing, so an array of things, and we are returning that thing. So notice how everything is connected here, and this is where the magic of generics starts to become clear. If you see the examples down there, TypeScript automatically figures out the type in each function call. So the types are actually figured out when you use the function, right? It's not figured out when you write the function. So there is two hats here. At some time you are wearing the author hat when you are writing these generic functions, and at one time you are the consumer. So you are wearing the consumer hat. Now, this will become relevant later. So let's keep going with some more examples. Generic types can't only be used with functions. You can use it with interfaces, classes, and even types. So right here we have an interface called wrapper, and that receives a value. And that value is, we don't know what it is, and we don't care. All we know is we are receiving a value as a generic type. Then in our function called wrap, it expects a generic type called value, and it's the first argument that's passed to it. Okay, so TypeScript will make that connection. Then it returns a wrapper of that value. So all that stuff is just to say we are returning an object containing a value that happens to have the same value as the one you passed. Now this will feel weird, but bear with me. So const count equals wrap 0, and TypeScript will resolve the count.value type to be a number. So if you pass a string, it will resolve it to a string. So it's really a dynamic type here. It's not, if we imagine a world without generics, you wouldn't be able to do this because overloading simply doesn't work. Imagine having to overload the function type for every single possible type that you can use. And then there's your custom types. You can't possibly, every time you add a new type, you add this overloaded version of that function. So we really need dynamic and flexible typings here. And this is what generics gives us. This count example should really look familiar to you because this is how refs work. Refs are generic type, and the ref function gives you a wrapper of that value. So right here we see this code is a JavaScript code. It's not even a TypeScript code, but you get some type information from it. This is what I mean when I say you are wearing the consumer hat. As a consumer, you usually aren't exposed to generics in any way. It's invisible to you. They happen behind the scenes, and this is, I think, if this is the case with your generics that you are writing in your code, then you are writing good generics if you are using them as types. Of course, there are other situations, but good generics are ones that are invisible from your consumers. Let's make the example a little bit spicy, I would say. let's say our wrap function only operates on a primitive types, and that includes numbers, strings, booleans, for whatever reason, doesn't matter the reason here, but we can apply constraints on our types. This gives you some leeway in your function code. Now, in your function code, you can treat the value as one of these 3 value types, and you can narrow it down and handle each type on its own, or you can treat the value in certain code paths as each of these value types. So if its type of value is a number, you can treat it as a number. It's unlike the previous examples. The previous examples, you basically had no idea what the value is, and you couldn't really operate on it because you have no idea what it is. Here, we are limiting what it could be. And through that limitation comes greater flexibility. So in the example down there, we try it with the various primitives, and it works until we pass an array, you will get a type error. So all of this is just to set us up for generic types in Vue.js. So how do they work, and is it just a recent addition, or were they around for a long time? Well, the answer is kind of both. I wrote an article on how to hack your way to get generic type components into Vue.js back in 2021. Then a year later, I figured a better hack to do it with the composition API. Then in Vue 3.3, it was finally released for us to use. And this is how it looks like. You have your component in your script tag, you add a generic attribute. And in the generic attribute, you type the generic syntax, or you type your generic types in there. This is what you would have written in the angled brackets if you are using classes or interfaces or whatever. In this example, we just define a component. This component has an items array that happens to be an array of that generic type T. Also, it has a selected prop, and it happens to be of that type T. Now, it's hard to imagine, so let's see how this could work. You would use them like this. You will have 2 instances of your component, and one of them is using numbers, the other is using strings. And the idea here is you can't mix them. You can't pass an options of numbers and expect the selected value to be a string. And you can't pass an array of strings and expect the selected value to be a number. You will get a type error. You will get strong typing here. And this is what we are trying to aim for. These types of errors could be discovered at the CI level. You can write a type check command in your npm package to JSON, and it will figure out these types errors, and it makes collaboration easy. It makes everything easier. So you can also write constraints in this generic attribute here. So it's exactly what you would have written between your angled brackets. You can also use external types to apply constraints on, but you import it from like the very next line. So it can get a little bit confusing, but this is how it works. So you import a type like item here, and then you can type your constraints on it. So how can you use this? Like, this all looks nice, but it's all theoretical. It doesn't really show you what's the advantage you get from making your code a little bit more complex like this. So I have a couple of examples here, and one is hard, one is a little bit easy, one is a little bit hard. So let's see how this all works. Right here, we have an input type demo. And in this demo, I have a really specific case that should look familiar to you. Now we have an input of type text. You can pass a type attribute to it. It can be either a number, or it can be either a string, right? Or text in this case. So the input text sometimes should emit strings, and sometimes it should emit numbers based on the type attribute. Now, this is a big problem, because how do we make sure that we are not passing the type number and receiving it in a string model or something like that? How do we type check this? And this issue comes a lot from, and you will see it in a lot of component libraries. When you are using them, they don't really try to parse the value for you. You will be advised to use vmodel.number or something like that. But we can do better. We can do something with generics here. So let's see how can generics make this component a little bit smarter. So let's add the generic attribute here. And first, let's think about this. What type of generic values are we interested in? Like, what's our generic type here? Is it the value? But if you think about it, the value isn't generic here. It's the type itself. So we have something called the T-type, and it can be one of two things. So these things right here. So let's cut that, and we can add a constraint to it, and we can say our type can be of the T-type, generic type, and can be one of these two. So here we will get some type error. I think this is a bug or something, but it's not an issue. You can just cast it to the same thing and it will work. This is safe because I'm casting it to the same thing, but I think it's an issue with the template TypeScript. So let's move on. First, I want to show you what's the issue with this component. So with this component, if I type something, like this used to be a number, right? This started off as a number, but it ended up being a string. This is a big problem. The other one is completely fine because it operates on strings only. So there are multiple ways you can work around this. You can cast the value yourself in the component. You can cast it in the consumer or the parent component. But the main thing I want to do is if I mix these, so I swapped the text ref with the number one and the number one with the text one, and I'm not getting any type errors, which is a big problem for me. I want to make sure that I'm using the correct value type with the correct type attribute. So we can, now how can we define our model? I'm using here the define model macro, and how can we make it so that it knows if the T type is actually a number, then it should be a number, and a string otherwise. You can do this with conditional types. So we can have something like type value equals, and I guess Copilot comes to rescue you. So if it extends text, it can be a string, or I prefer to do it the other way around. If it's if it extends a number, then it should be a number. Otherwise, it will be a string. Here with TypeScript, conditional types are being, you can do conditional types using the extends keyword. So extends and the ternary, you get conditional types. And then in our define model here, you can do this. And let's not fix the issue here. Notice that we immediately get type errors here. And this is because string is not assignable to number. And if we check the other one, number is not assignable to string. And this is because of the type attribute. And I can prove it to you. Let's change this to be text. The error goes away. And if I change this to a number, error goes away. And this is exactly what we want to achieve here. So I will bring them back because I mixed them a few times. So, and here let's fix this. So we need the props. So we can grab the props from define props here. So we can say if props dot type is a number, then cast it to a number. Otherwise, cast it to a string. And we get type errors here because it's a little bit hard to make the connection between this and the past type. So it's fine. We can just cast it here because we are sure that it's behaving as expected. It's a mix of runtime plus typings. And then if I reload here, the number value is maintained and the string value didn't have an issue to begin with. So this is just one use case of this. So let's go back to the presentation and see what we have more here. I think the best components that make use of this feature or can make use of generics, especially are lists, selects, and tables. Any component that has a slot prop that's meant to be overridden. So let's say your post tells you need to have a select input, so you create it. It needs to select the tag, right? So you assume it's an array of strings. So you design your component around that way. Of course, you can use a third-party component library, but let's say you're just building one. And then okay, it accepts an array of strings. The model is a string, straightforward. We created it. It works. Everything is fine. However, your boss then comes and tells you, we need to have a field for selecting a speaker. And this is a sudden issue for you because you know it's not compatible. You know you have an array of strings and it can't possibly overlap with an array of objects. So it becomes an issue for you here now. And it's not an issue in customizing how each dropdown looks like because we can already do that with slot props. However, it's an issue with types. How do we make sure that the types still work even though the component is basically operating on completely different types? And to make matters worse, Worse, your boss then tells you, let's build a field for the country. And now it's even a bigger issue because you are dealing with any kind of objects, and you might be even dealing with primitive strings. So it can get a little bit complicated here, and we need some dynamic, really some dynamic typings to get this to work fine. So without generics, and this is something I saw with a lot of component libraries, is they force the option to look like a certain object. Like they tell you, okay, our options always look like a label and a value. You can't have anything else, or an ID and a label, and so on. So we have a better way to do this with generics, and I will be showing you how. So right here we have the select the demo. Let me switch to it. And we have 3 drop downs here that these components I have created from scratch. And they have the speaker. Once I select the speaker, it's there. Same thing for the category. Same thing for the country. So it works pretty well. However, that's how it works as a function. Okay, let's see how it works in our template. As a consumer, how does it work? Is it fine? Is it fun to use? Or is it completely horrible? And I'm a bit opinionated here, but I think this is pretty horrible because we have 3 different value types. We have speakers, and we have tags, and we have countries, and they all look different. They don't look the same at all. And our input select component is forcing you to pass an option that looks like this. You must have an ID, you must have a label, and this extras object is a hacky way for you to inject certain properties. Like here, we want to pass the image URL back to the slots here. This is scoped slots, and we are overriding each option. So we want to be able to override this, and we want to be able to pass the image through. Now, is the image type? It's not. It's typed as any because we typed it as such. It's a record of string of any's. If I remove this, well, it doesn't work anymore. You get type errors here because it doesn't exist. Now, let's say I try to do this. Let's say I want to get rid of the extras object, and I want to pass the image URL as it is. Now, if I try to use the property directly, of course, I will get a type error. However, if I reload the code, it still works. And this is because it's runtime-wise, it works. You are passing an option, and you are using a property on that option. But your component cannot make that connection type-wise. It cannot make the connection that the options you passed are the same thing that's going to be exposed here. This is where generics comes in. So first, let's get rid of this type option completely, and let's add our generic type here. Naturally, it's going to be of that. It's going to be called type T option. And I like to prefix my generic types with T or U or stuff like that, just because it makes it clearer for me that it's a generic type. It's not imported from somewhere. It's not defined somewhere in the code. It's a generic thing. So we can go about this in totally different ways. So let's start with the closest approach, which is we can define it as a constraint. So let's go to the types file, and then we can export our type option here. And it's exactly the same one, but we have removed the extras object. And then we can say it extends the option, and we need to import it. So import type option from my types. And then components seem happy, right? However, we aren't done yet. We need to replace a few things. So we are still using option around. We need to use T option instead. So let's replace that, and replace that. And I think we're fine. So now notice all the type errors are gone. And everything still works. We didn't even change our runtime code. We just added the generic type, replaced a few things, and it keeps working. And this is the best thing about this. So let's say I remove this completely. I get a type error. So it says, because it says image URL doesn't exist. Now it's connected. Now the slots are making the connection between each one's option and the props that you have passed, or the options you have passed. So I think this is pretty amazing, if you ask me, but we can do better here. So let's do this for the countries. Let's remove the extras completely. Let's add the flag explicitly and remove the extras. And notice that I get type auto completion here, because it knows what the type is. So everything still works. Okay, so this is what I would call level 1 of making this component generic. Like, we can go a lot of layers to make this even more reusable. So let's think about how this component ideally should work. I would say that I prefer for this component to avoid any kind of mapping. Like, you could map, sure, but I want to be able just to pass the speakers and get type information here and just display them. Now I'm not getting anything here because it can't make that connection. Why? Because it has to extend the option. This is a constraint. So let's remove that constraint completely. Now you can pass me anything. Anything you want, you can pass. And then we get a few errors here in the component itself, and this is natural because previously we relied on having an ID property. Now we don't. So how are we supposed to make the keys here? Same thing for the label. How are we supposed to generate the labels for this component? So let's try a few things here. We can start by having a function called toKey, and it should receive an option, and it should return an ID for it. The ID should probably be a string, maybe. It can be anything really, but let's make it a string. Now, there is no good way to make this work without making any assumptions about the kind of object. So we can avoid that by just stringifying the option. And this should be unique enough, right? And then we can just pass the option itself for the key. And let's do the same thing for the label. So toLabel, and then we can stringify the option itself. So it's not JSON stringify, it's just a string, which will become clear in a minute. And then we can pass it here. Okay, so this component is happy, this is not. So let's see what's the problem here. It tells us that, well, image URL is there, so that means it probably made the connection correctly, right? So if we try to complete the property here, it made it. Like, we didn't have to map anymore, and it made the connection correctly. So sorry, I switched the language, and same thing here, just replace it with name, and let's get rid of all this mapping because it's way cleaner without it. So here, I think it's named country, and I get to completion. I don't even have to guess. So if I reload, everything still works exactly the same. Now we can go a step further here. So, I mean, we can do a lot of things with this. So here is a fun idea. Let's say we aren't interested in displaying any kind of avatars for the speakers, and we just want to display their names in the dropdown. So let's remove all of this. This is what we want to have here. We want to be able to do this. Now, if I click save, of course, we get a problem. Stringifying an object will always result in this weird string that you probably seen all the time. So how can we fix this? Well, we can accept a prop called option label, right? And this function should receive the T option and it should return a string. Now, in the toLabel function, we can make that check beforehand. So if props contains an option label, then we call it. Of course, props isn't defined yet, so we need to assign it here. And then still not working, of course, because I didn't really do anything yet. So I need to pass option label, and then let's extract the username. And I get type completion here as well. That's the best thing about this, right? So I can extract anything I want as a label, and I just save. And now we are displaying the names without really doing anything else. So this component can go from being really simple like this to having a custom slot that displays certain things, and it's really nice. Like, this is what I like most about having generics, is it allows you to keep digging further to make the developer experience much better. So right here, we didn't make a lot of changes to our code, actually. Like, the diff is minimal, but it allowed us to have selects that has native strings and complex objects like this, and it just works. And this is not even a component library or anything. This is something I just built with a few lines of code, some styles, and that's it. So This is what I like the most about generics. It's really powerful, and if you find opportunities to use it in your code, it will just pay dividends for you and your team. So you can find the code here, but I will go through a few more examples, but I don't have a code demo for them because we don't have time to show everything. So here is a few ideas that you can use with this generic thing. You can use them with checkboxes. You will be like, okay, checkboxes, this is a little bit weird. Why would I use them with checkboxes? Well, checkboxes are a very complicated component state-wise. And here is the thing. Checkboxes and toggles, they are used almost exactly the same thing in a lot of cases. And checkboxes can toggle between two values, not just booleans. It can toggle between any two values. And Vue actually supports that using the true value and the false value when you are using the native checkbox element. So here I'm toggling between yes and no. So to make the V model type safe here, you would need to have two generic types here, one for the truth value and one for the false value. And then it will be type safe for you, just like we saw the input text and just like we saw with the input select. Here is a bigger example. Let's say you have a list of things and you are right-clicking on one of these things. Now, you can have your context menu as a generic component. This is a bit far-fetched, but this is actually how I use generic components in my code. At my work at Rasail, we have this floating container that accepts a value as kind of the context value for the menu. And this means I don't have to create a menu instance for every single item here. I can just have one, and it will be passed down, and it will reflect in everything. It will reflect type-wise, it will reflect in auto-completion, and I don't even have to write a state specifically to track which item was right-clicked. So yeah, go generics, I guess. I am pretty much done here. So I'm ready to take some questions.
Wonderful. Thank you. And we do have quite a few questions. So let's see. How can developers effectively define and use type constraints for the generic types of their components?
Um, well, this question is a bit ambiguous because there are many ways you can do generics with. Like I showed you a few ways here, but I think it's more about you using generics more than not using generics. So let's say I just showed you a couple of components that with input text and input select, and it's really weird to use generics with input text and checkbox, but there is some benefits to be gained. So I would say you can use type constraint here and stuff like that to force your components to really do one thing really well and still allow for a room full of flexibility. So I think there are two ways to go about this. Either your component expects a certain type or an extended type of that type. Then you would use type constraints. Otherwise, if it's just like our select component, it doesn't really care what kind of option you throw at it, then you shouldn't use type constraints. It depends on what your component is doing and how much flexibility are you willing to allow.
Great. Thank you. All right. Are there any potential challenges or trade offs associated with using generic types in Vue, such as increased complexity or learning curve?
Um, I guess there are some learning curve to learn with generics because they are such an intimidating feature because they can do so much. You can have like 3 generic types in the same components if it's really complex. You can have really strong constraints. So it will add a lot of complexity. It will add a lot of learning curve depending on how you are planning to define them in your code. However, what I would say is make sure that the complexity you are adding isn't standing in the way of your team. It may seem so at the beginning that generic types is just refusing anything, like your components now refusing the props, it's refusing view model, it's being a little bit like angry about any type you throw at it. This can be seen as I would say, standing in the way of your productivity in your team. However, it's not. These type errors actually mean that you passed the wrong thing. There is a strong chance that your component in runtime will not do the thing it's supposed to do correctly, just because you sent something wrong or allowed for increased flexibility here. So I would say it's definitely a trade-off. It adds complexity to your code, it adds complexity to your components, but it adds so much to it, like developer experience to it.
Thank you. And can we use type guard functions to avoid casting? By the way, thanks for the VeeValidate.
Yes, you can use type guard functions to avoid casting, of course, but that will only work with generics that are constrained to a few types. So you would now have a union. So now type guards would work against that. However, with something like our input select component, the T option is now basically without any constraint. It becomes effectively unknown. You can't really make any assumptions about it. Sure, you can try to type guard it with the type of and I guess predicate type functions. You can do that. It still works. So yeah, you can definitely do that.
Great, thank you. All right. Second to the last one. The red hint on the warning is awesome. What is the name of the plugin?
I get this question a lot. It's Error Lens. It's a really amazing plugin. So yeah.
Okay, error lens. And how can I identify a good use cases for generics in a project? Are there any symptoms or signals?
I would say it depends on your use case, of course, but there are, to me at least, there are telltales of this. Definitely, this component definitely needs to use a generic. It's when your component receives a prop and re-exposes something related to that prop in a scoped slot, or it emits that value back. So that to me like screams this is a generic function. This should be a generic component.
Great. Thank you. That gives us all of our questions. And thank you for joining us today.
Thank you. Glad to be here.